Multi-indexing is one of the most important topic of the algo trading because whenever you fetch any data from any source, you will be getting the data majorly in multi-index form, and it has become a series, right? If you check the type of this, you will see that this is a series, right? Means we can say we can convert from a series to data frame or from a data frame to series with the help of unstack and stack. Now we will create a series and a data frame from the multi-indexes we created. So first let's create the series. So for the series, we know the syntax pd.series and you have to pass your index. So hello friends, welcome back to day 30 of the 100 days of hell with Python algo trading. Guys, we have completed a whole month, the 30 days, and it is really an achievement for all of us because the amount of consistency which all of us have shown is incredible. So thanks a lot all of you for believing in us, for trusting us, and we promise that we will never ever break the trust. And yes, also in these 30 days, we have made so many mistakes, but we are improving day by day. We are putting a lot of efforts in everything, in the video production, in the content creation, and also the website management. It really becomes hectic, but we are doing that happily because we know we are providing high value. And I'm sure that each day we are improving everything, right from the production to the multiple choice questions and to the task and the mini projects. So with that being said, let's start with today's topic, that is multi-indexing. Multi-indexing is one of the most important topic of the algo trading because whenever you fetch any data from any source, you will be getting the data majorly in multi-index form. So far we have understood the index, the 1D, 2D and 3D, and the column names, the column values, but now we will understand the multi-indexing. And guys, believe me, it is very easy. You just have to stay focused for a few minutes and you will see that how easy it is. And we'll make sure that after this session, we'll provide some multiple choice questions and some tasks with a mini project. So you will gain more clarity. And let me show you which kind of data generally you get when you fetch data from multiple sources. It can be an API data. It can be a directly downloadable data from any source. So let me show you generally in multi-indexing what kind of tables we get and how we want to convert them from 1D, 2D, 3D back to 3D, 2D and 1D. It's very easy. Just you have to apply your logic in a correct way and you will see that it is absolutely easy. I would say it is very important but very easy. So without a further ado, let's get started and let me show you how it works. Okay, let me first explain you that what is index and what are the column names. So we have seen previously in the series that is 1D and data frames that is 2D. So let me show you. Let's say we have a series and in that we have a default index of 0, 1, 2, right? And values we can have, let's say anything here, let's say 100, 200, 300 and 400. So this is the series, right? And series are generally 1D. Not generally, always. Okay. So here, this is the index and these are the values. Again, let's say we have a data frame. So in data frame, what happens? It will nothing but it will just change, let's say 0, 1, 2, 3. The values are same, 100, 200, 300 and 400. There will be another column, right? So it can be 500, 600, 700, 800. And you can say this is the price after inflation, anything it can be. So price inflation, correct? So we have here two columns and all of it becomes the data frame, correct? And when we take any single column, it becomes a series, that is 1D. So here it is 2D because in the series, in the 1D, when we want to fetch any value, let's say 100, we just need one information, right? The name of the series and we just need the index number. So if I just give 0, I will get 100, right? Here it will be the name of series. And when I give the index, I'll get the value. So that means in the 1D, we just need one piece of information to fetch any value. That proves that series are 1D. And now in data frame, we know that data frames are 2D. And to fetch any value, let's say 600, we need two pieces of information, right? If I write the name of data frame, then I have to provide the row number, which is 1. I have to write like 1. Then we have to provide the name of the column. So that is price. And then only we'll be able to fetch this information. And that also proves that data frames are 2D objects. Okay, now let's start with the multi-index. So in multi-index, what happens? Instead of having only one level of index, we have multi-level of index. How? Let me show you. So here you can see that this is the live data which we fetched from the Yahoo Finance, and I will also show you today that how to fetch the data from Yahoo Finance. We'll code, and it's very easy, and I'll show you how you can also do that. So here you can see that we have a date time index here. Then here we have the column name, that is adjacent close and close, and below that we have the name of tickers: Apple, Amazon, Google, Microsoft. So this means in index we have a date time index, and in column we have two level of column, right? So sometimes you might have to convert this kind of table to this kind of table. And here, if you can observe that we have a two level of index, right? So first we have the date, and then we have the ticker name, right? So we can say this is level 0 of multi-index, and this is level 1 of the multi-index. So similarly, here in the column, we have only one level. So let's convert this table to this table. I'll show you how you can also do that. So here we can see that we have a date time index, or here we have two level columns. So in algo trading, you will always want to convert from one dimension to another dimension. And we can say that multi-indexing is generally used to convert higher dimensional data to a lower dimensional data to perform better analysis, because we are comfortable with the 1D or 2D data. And we can also perform better and efficient analysis on the lower dimensional data, that is 1D and 2D. That's why we'll always converting from a higher dimensional to a lower dimensional. It can be any dimension. It can be a dimension to one dimension. We can easily convert once you understand this concept. It's very easy. You can also convert like this. The columns came in the index, right? So now it becomes very easy to observe. And you can also convert like this: date will come first and ticker will come to second level. So you can always easily change the column level, the position of the columns or the indexes. So means once you learn this, you will be able to play with the data very easily. Okay, so now let's understand the multi-index object. Let's see some theoretical part, and then we'll proceed for the coding part. So in algorithmic trading, data often comes in nested hierarchical structures. For instance, you might track the performance of multiple trading strategies across different time periods and asset classes. Multi-index objects in Pandas allow you to organize this data hierarchically, making it easier to navigate and analyze. Now let's understand why we use multi-index objects. So the first point is hierarchical data representation. It allows you to represent complex trading data structures, such as tracking various strategies across multiple assets and timeframes. Means we might want the data of multiple assets across multiple timeframes, and in that case we will be always having the data in multi-index form. So it becomes absolutely necessary to learn this concept. Then efficient data manipulation. It enables efficient slicing, dicing, and aggregation of data, which is crucial for backtesting and analyzing different trading strategies. So means when we fetch multiple assets data in multiple time frames, so then with the help of multi-indexing objects, we can easily navigate, we can easily slice the data, and that is crucial for the backtesting. And the last but not the least, enhanced grouping operations. So it facilitates more detailed group by operations, essential for calculating metrics like strategy performance by asset class or time period. So it becomes absolutely necessary to learn this concept thoroughly, deeply, so that once we start the algo trading, we'll not having any issues. So actually, after this topic, we have few sessions of the advanced pandas, and then we will understand few plotting libraries, which is very crucial for the algo trading, because we always want to first analyze and then plot. So it becomes necessary to understand the plotting libraries also. And after that, we'll start the deep concepts of algo trading, and you will see that shortly. Now let's understand the coding part of this multi-indexing, because the practical side is more important in the multi-indexing. So without a further ado, let's deep dive in the coding examples of the multi-indexing. So now what we will do today, I'll first show you that how you can extract data from the Yahoo Finance. So for that, so first of all, when you start coding with the pandas, you have to import the library, that is the pandas. So import pandas as PD, And as I told you previously that along with pandas, make a habit of importing numpy as well, right? So import numpy as np, and then for Yahoo Finance, you have to import the library that is yfinance. So import yfinance as yf. Sometimes what happens that it is not installed in your system. So for that, what you can do, you can select any cell and you can write pip install yfinance. Okay, so it will get installed. So when I hit shift enter, you will see that it says requirement already satisfied, means it is already installed. And sometime what happens, it might also not work, because for the Python 3 you can use that. But still, if it is not installed, please let me know. I'll help you out in the comments for sure, or in the Discord, or in Telegram, or in Instagram. You can connect with us and we'll try to help you out. Okay, so now we are set. So when I hit shift enter, it will show me a tick, means it is all imported, right? Okay, now let me show you a simple process in which we will just import a data of a single ticker. So for that, what you can do, you can just write yf.download. Okay, so inside that, you can see that we have some default parameters. So we have tickers, then we have period, interval, start, and a group by. You can use a lot of parameters, but that is not required a lot of times, right? So what we can do, we'll just use the tickers. Okay, first of all, so I'll just write tickers and I can just give Apple, right? So when I hit shift enter, it will download the default that is from start to end, right? Then, like if I want to give a specific time interval, so for that you can give, and in start you can mention the date. So let's say if I want to fetch data from 1st January 2024, and in and you can provide date of today. So let's say 2024, and let's make it 1st of June. Okay, so now when you hit shift enter, you will see that instead of these rows, we'll be having less number of rows. So let me hit shift enter, and we just have 105 rows, and we have 6 columns. So if you remember, I have shown you previously that these are the general OHLCV data, it is open, high, low, and close, and volume, and also adjacent close. So if you are having any issue in this concept, please refer my previous videos and you will find a detailed explanation of this OHLCV concept. Now, when you are performing any analysis, like whenever you analyzing a data, it's always advised and recommended that you create a function to specifically fetch data. So for that, what we can do, we will make a function. So for now, I'll just keep it here only, and I'll assign a variable to this, that is data, correct? And we can define a function here. And for the function, we have done a detailed video. You can find the link in I above. And if you have any issues, please refer that. So define fetch data. You can give like fetch data. And so now it's good. And here also I can return data. So whenever we call this function, it will return data, right? And also we can remove these parameters. So what we can do, we can pass here tickers, then start, and then and, like this. So I'll just remove it from here and this also. Hopefully it's clear, nothing difficult here, which we have studied in detail in previous videos. Now let's do few more things. So as here we want multiple tickers. So for that, what I'll do, we can just like give some value here. So we know that we want data for multiple tickers. So what we can do, we can pass a list here, list of tickers, then the start date and the end date. So in tickers, I'll give a list. So let's say Apple. I want for Amazon also. Then let's say Meta and Microsoft. Okay, so I'll just take 4 tickers, enough. Then in start, I'll give a date. So 2024. to 1st January 2024 to I want data up to 1st of June. Okay, so now all good. So when we call this function and provide these values, it will be printed out. Now what we can do, simply we can assign to a data frame, that is df, right? And we can simply print it. So I think it's all clear. It's very easy. This one we have learned in the previous videos thoroughly, so you can refer that. And now when I hit shift enter, you will see that we have a data frame, right? And which contains 105 rows and 24 columns, right? Means in columns, it is multi-index. We have two level of columns, level 0, adjacent, then close and high. And on the level 1, we have Apple, the ticker names. Here also we have a date time index. Okay. We can also check with the info command here. So let me show you info, and you will see that we have the columns, correct? Then there is no null value and all are float 64, right? And the size is 20.5 KB. So mainly we have two kind of data types, that is float and integer. And you can also check the index and columns. So let me show you index. We have datetime index, correct? And in columns, we have this, that is multi-index, right? So now let's begin the session with very basic. We'll build up the basics, the fundamentals, and then we'll move to the advanced topics. Okay. So df, we have this data. I'll just keep it, and I can show you also. It is the type. You can see here the type data frame, right? So we'll use this later. So just remember that we have a data frame with the name df, which is the data of Apple, Amazon, Meta, and Microsoft from 1st of January to 1st of June. That's it. Okay. Now, series is 1D and data frames are 2D objects. So why? Let me show you. So if you want to create a 1D series, what we do, we simply use the method that is series, or inside that we can pass a list, we can pass a single number, we can pass a dictionary, and a series will be created, right? We have seen that previously. So let's say if I pass a list of 1, 2, 3, 4, 5, we'll get a series, correct? You can check the type. This is a series, correct? If you use the data frame method or object, you can say, so we will get a data frame, right? And it will look like this. Let me show you. It will look like this, correct? And we have seen that if you want to convert a data frame to a series, we have to use the squeeze function. So this is the basic series and data frame. And let me print both of these so you'll get more clarity. Print, and here also print. So you will see that both looks almost same, like there is not a much difference, but they are still different, series and data frame. So if you want to convert, you can use squeeze. And here, let me show you some of the important things here. So here is the index of series. This is the index of data frame. These are the values of series, and this is the value of data frame, correct? And for now, we know that series are always 1D. Why 1D? Because to access any value of series, we just need one piece of information, right? And to access the data frame, we always need two pieces of information. Let me show you how. I'll just assign some value to these. So let's say series, we assign ser, and for data frame, we will assign, let's say df. Okay. Now, I'll just add another column here. So series. Okay, let me run this. And now what we'll do, we'll print ser and df both. Let's print, so we'll get a more clarity. Print, and here also print, correct? Now, if I want to access the three value of the data frame, I need to provide an index, and you will get the error, right? Because to access any value from the data frame, we have to provide two pieces of information. So this was the row first, and now we also have to provide the column. Similarly, if you want to access these three, from the data frame, and let's say if I write df and 2, but it throws a value error. It says 2 is not in the range. So for that, what we can do, we have to use the iLock, and we have to provide 2 pieces of information. So when I write iLock, so actually by default, if I shift enter, it will give me the value, that is 3. But when we have multiple columns, we also have to provide the column name. So here we know that it is 0. So I can just give here a comma and 0. So we'll get the same value exactly, right? No difference. So now I hope you are able to understand the difference, the real difference between a series and a data frame, right? So here in both the series and data frame, we had a single index, right? Or even in the column, we had a single level of columns. But if I want to create a multi-index series or multi-index data frame, what I can do, I will go here and I'll just take this only, this list. I'll go here and let's say I'll give an index here, multi-index, and I'll pass a list. And what I will do here, I'll add a tuple. So we can say this is the list of tuples, right? So I'll add some value here. Let's say apple, and I'll just copy and paste it everywhere. So 2, 3, 4, and 5. Now we can change the values. So from Apple to, it can be Microsoft, it can be Meta, it can be TCS, or it can be IOCL. Okay. And let's change these values also. So to differentiate better, 3, 4, and 5. Just remove this unnecessary comma from here. So now what we will do, we will just pass this index as the index of series and data frame. So I'll go here, I'll write index is equals to the m index, right? That is the list of tuples, right? And here at the values, we can give anything. So in series, let's say we provide a list of values. So it can be 0, or let's say provide from the 1. So 1, 2, 3, 4, or let's give some good values, 100, 200, 300, 400, 500, because we'll not be able to differentiate between the index and values. So now when I hit shift enter, you will see that we have the values, but we don't have, because we made a mistake. We have to change these to m, series, and multi-index data frame. Now when you hit shift enter, you will see that the multi-index series has been changed. Now we have 2 indexes, that is multi-index and the values of the series. Similarly, we can change for this also. So here what I will do, I'll go again and copy the index, and same process at the index, I'll provide the m index, the same index, and in the values, I can give the similar values, right? I'll go here and I'll provide the similar value. So when I hit shift enter, you will see that it has been changed, correct? So now the values are same exactly, but this is series and this is data frame, because you can see here, we specifically created one series and one data frame. You can even check if you want, right? Okay, now let's access this multi-index series and multi-index data frame, right? So what I'll do here, I'll go here and I will try to access. So we know that to access the multi-index series, that is 1D, we just need a one piece of information, that is m, series, and just the index number. So here we have the index number as, let's say if I try to access with just the apple, let's try what happens. It will throw an error because we have to provide this specific index, the whole one. So I'll just paste it here. And now when I hit shift enter, it says apple not defined. Yes, of course, because we have to make it as a string. Now when we hit shift enter, you will see that we have the value, right? That is 100, correct? Similarly, we can also copy and paste in the data frame. So I'll just change from series to data frame. And now just pause the video and you let me know whether this will work or not. If yes, then how? If no, then also how. You have to understand, you have to pause the video and you let me know it will work or not. And you have to provide that why it will not work or why it will work, right? So, okay, now let me hit Shift Enter and you will see that it's raised an key error, right? Means we need two pieces of information to access any value from the 2D data frame. So we have to provide the index number and we have to provide the column number. So for that, I'll just remove this, right? I want to access 100, so I'll provide 0, that is the row number, and the column number is also 0. So I'll just give 0 and 0. And when you hit Shift Enter, you again have a key error because you have to use the iLock here. We have learned that, right, previously. So when you hit Shift Enter, now you have the value 100. So I think now you are able to understand the real problem. So means, let's say if we fetch the data from any source and we have a 3D, 4D or even a 5D data, then how you will access? Because it becomes more and more difficult to analyze the data and manipulate it in the higher dimensional data frames. So for that, we need to reduce from higher to lower, and then we can easily perform the operations, right? Here you can also just provide the 0 because it has only one column. So obviously it will give only 100, right? So the problem in this kind of multi-index that we cannot simply access a single index. If I want to access Apple only, I cannot do that. Let me try that. So when I provide lock and if I give here only Apple and hit Shift Enter, it will throw an error, key error, right? Here also in series, if I just give Apple, it will give me an error. But in reality, sometimes we need only Apple value, sometimes we need only TCS value, sometimes we need only IOCL value, right? Now what we can do, we can simply create the multi-index object. So pd.multi-index, and then we have to give that from. So we can create a multi-index from product, we can create from arrays, we can create from frames, and we can also create from tuples. So for now, we'll just look on how to create a multi-index from tuples, and then we'll look on and how to create a multi-index from products. So from tuples, and we know that we have these tuples, the list of tuples. So what I will do, I'll just pass simply mindex, and now when I hit Shift Enter, you will see that we have a multi-index, correct? Now, similarly, you can also create from the product. So for that, what I will do, create a product. So for that, I will do like product index, and I can pass a Cartesian product here. So how you can do that? You can simply remove this and you have to create a 2D list. So first, let's say we give Apple, and then we can give, let's say, Microsoft, right? And here give a comma, and you can give the values. So what will happen now, this Apple will get multiplied with 100, 200 and 300, and again this Microsoft will get multiplied with 100, 200 and 300. Let's make it 6. So what I'll do here, I'll remove this 300, and here I'll give another, let's say, Meta. So I'll just copy and paste here. So we'll be having 3 multiplied by 2 means 6 values. So here also let's make it 6. So I'll add another value, let's say HPCL, okay? Just for the symmetry, nothing else. Now, if I want to create a multi-index from product, so for that, what I will do, I'll just write pd.multi-index. Then from, we have to select product, right? And here we have to pass the Cartesian product, so p index. Now when I Shift Enter, you will see that we have a multi-index of 6 values, right? 1, 2, 3, 4, 5, 6 means this Apple got multiplied with 100 and 200, then again Microsoft, and then again Meta, right? Now what we will do, we will just assign some values here. Let's say what we can do here, tuple. So t index, and here we can provide it value, let's say p index. Let's change it to something else, pp, just for now, so it will not conflict. Okay, so now we have 2 multi-indexes. One is t index that is made from the tuples, and p index that is made from the products, right? And now we will print this. So print first the T index, and then in the next line, we'll print the P index, right? You can see here, we have both the indexes, right? All have like 6 values, 6 and 6. Now, if I want to check the levels, so what I can do, I can write T index and dot levels. It will show me the frozen list, right? And inside that, it will show me both the levels. Let's say if I just want the first level, these tickers. So I can just pass the index 0 and we'll get only the tickers. If I want the numbers, I can give here 1 and we'll get the level 1 index, right? Similarly, you can do in this also. So for P index, I will just change it. And in P, the level 1 is these values, 100, 200, right? So when I hit shift enter, you will get the 100 and 200. And for the 0, you will get all the tickers. So hope it's crystal clear, right? Now let's understand that. Let me just copy it, paste it here in the respective columns, right? Now we will create a series and a data frame from the multi-indexes we created. So first let's create the series. So for the series, we know the syntax pd.series, and you have to pass your index. So first we will give, let's say, the tuple index, right? So when you hit shift enter, it says initializing a series from a multi-index is not supported. Means actually we want to use this multi-index as the index. So we have to first give index is equals to multi-index, that is a tuple index. So now when I shift enter, you will get these values. And here we have only the indexes. There is no value because we haven't provided, right? So for the values, you can give here anything. So let's say we pass a list here and the values are 100, 200, 300, 400, 500. The index is 6. So we have to provide the 6 values. If you provide less values, you will get an error, right? It will say length of values 5 doesn't match the length of index. So you have to provide the 6 values. You will get a beautiful series, right? With the multi-indexes. And now our problem has been resolved. Earlier, if you remember in the above, here, we cannot access any value with just a ticker, right? We have to provide the whole index. This, then only you'll be able to access. Let me show you again. If I provide only the apple, we cannot get the value, right? So to access the value, you have to provide both the indexes, right? Then only you get the value, correct? The 100. But now the issue has been resolved. And if you want to access the first value, what you can do, let me make it a series. So what I'll do here, I'll give it a name M series, M-S-E-R, and just print this here. And now let's say if I want to access the 100, so what I can do, I can simply write msir and give the index number 0. If I want the first index, we can also give here apple and you will get the first value. And now if you want to apply like the iLock, it will work similarly. I can even give iLock apple, it will not work because we have to give the index here. So I will just give the index 0 and you can get the value. So now we have the flexibility with the multi-index object. So the difference is we can create a multi-index series without the multi-index object, but we cannot get that flexibility. So with the multi-index object, we are having a good flexibility, and I'll show you more on this, right? Just wait for a few minutes. Okay, now let's create a data frame. So what I will do, I'll just copy it and paste it here, and I'll change from series to data frame. Okay, from series and here also df, and here series to data frame, correct? Everything is same. And now when I shift enter, you will get the exact value, but now little bit more beautiful in a tabular form. You can see here it is same, little bit better. The only difference is that we have seen previously multiple times that to access as value from a series, we just need a one piece of information. Why? Because series is 1D, but to access the information from data frame, we need 2 pieces of information because this is a 2D data frame, right? Okay, now let's say if you want to access the 100, what you will do, you can simply go and write apple, right? Which we have done in this series, and you will get an error because we need 2 pieces of information. So for that, what you will do, you will give here LOC, correct? And now when you hit shift enter, you will get the value. But this is not correct because here only one column. So that's why we are getting the first value. But if we had multiple columns, we would be getting all the values, but we want only the 100. So for that, you can just give a comma here and you can provide the column name also or number. So here, when we give 0, you will get exactly the value of one cell, that is 100, right? Hope until now it should be very clear to you, correct? Similarly, we can use the same things, ilog and log. So for ilog, you have to provide the indexes in the integer form. So you will give 0, 0 and you will get the value, right? Exactly same like the series, correct? So we have seen that how to fetch the data from a series or from a data frame, correct? So now the logical question arises that what is the use of this? So we can simply create a data frame or a series and we can perform all these things, right? So my answer is that now you have the flexibility or to convert this data frame to a series, and that is done with the help of two amazing functions, that is stack and unstack. Let me first show you the unstack. So we have this series here, small num series, and if I apply unstack here, so what will happen? This level 1 index will be unstacked and it will go to the columns. So when I hit shift enter, you will see that the level 1 index has become the column and it has become a bigger data frame from series. So we can say we have converted this series to a data frame, right? If you again apply this unstack, and now you can also stack this, means you can also bring this value again to the level 1. So for that, you will do stack and you will see that it has again become the same, right? Okay, now let me show you the same thing for the data frame. So this is the data frame MDF, correct? And when we apply the unstack, the same thing will happen. This level 1 index will go to the columns. So when I hit shift enter, you will see that it has happened. And again, if I apply stack here, it will reverse that, right? Okay, now let's use the real data which we fetched from the Yahoo Finance. So if you remember, I showed you here, we fetched this data, this DF from the Yahoo Finance, and now we will use this one, right? So I'll just run it again, and we know that we have this data frame, and here we have the multi-indexes. So I'll just go here and just print DF. Okay, and now let's apply the unstack here. So what will happen? This index will go to the here. So when I apply unstack, you will see that the date index has gone to the top and it has become a series, right? If you check the type of this, you will see that this is a series, right? Means we can say we can convert from a series to data frame or from a data frame to series with the help of unstack and stack. So if I just apply again stack, it will become the data frame again, right? It says series object has no attribute stack. Actually, on series, you cannot again apply the stack. First, you have to unstack that. So what we can do, I can show you on something different. Let me show you. So when I hit shift enter here, let it leave here. And what we will do, we will first apply the stack. So let me apply stack. And now what will happen? First, let me show you the original data frame, right? Now what we will do, we'll apply the stack. So what will happen? Here we have this level 0, this adjacent close, close and high. And on level 1, we have the tickers. So if I apply stack, what will happen? This level 1 will come at this index positions, right? So stack, and you will see that this ticker has come to here. And if I again apply stack, this level 0 also will come here and it will become a series. So let me apply stack again, and you will see that the price column also became an index here, and now it became a 3-level index, level 0, level 1, level 2, and this is the series now, right? So I wanted to show you that we can also unstack this. So first we applied the stack, okay, and now if I apply again stack, it will become a series, right? Let me show you type series, right? So if I apply again unstack, what will happen? The series will become the data frame, means the inside index will go to the column name. First it will go. So let me apply the unstack, and you will see that it has gone to the upper. And if you now check, it has become the data frame. Let me show you, right? And again, what you can do, you can reverse your changes. So if you want this tickers on the column side, you can apply again the unstack and it will go there. So now it became the original data frame because we first applied 2 stack and again 2 unstack. So it crossed all the changes. And if you again apply unstack, now what will happen? Now this data frame will become the series, correct? Hope it's clear now, crystal clear. And if you have any doubt, please let me know in the comments. We will try to answer that. Okay. Now again, the question, what is the point of multi-index series? So we have seen that dealing with lower dimensional data frame is much easier than the higher dimension. Means we can easily perform any analysis on the 1D series better than the 2D data frame. Let's say if you have multiple 3D data frame, we have a 4D, then it becomes hard and hard. So let's say if we have 4D index, so what we will do, we'll apply twice the unstack and it will become a 2D index, and then we can easily perform. And if you want a 1D, then you can apply 3 times unstack and it will become a 1D index. Then again, you can easily perform the operations. So that's why we use the multi-indexing to convert from any one dimension to another dimension. So you can convert from 1D to 2D, you can convert from 1D to 3D, right? And similarly, you can reverse that. So yeah, that was the explanation. And now let's understand few more things. So now the question is, are columns really different from indexes? No, because this Pandas treating both as the same. Means sometimes we can easily convert an index to a column name and a column to an index name. Means for internally, Pandas both are same, both are equal. And we have seen that multi-index DF from the column perspective. Let me show you again. So here we have 2 level columns. So if you want to make it 3 level, so you can simply convert from a data frame to series, right? And it will become a 3 level, right? And if you unstack this, then what will happen? The index will become 2D, right? This will become here. And again, if you apply, the column will come in at the indexes. So it was just that we can make like either column also multi-indexes, we can make index also multi-indexes, right? Actually, we have done this also in the above, that we have worked on both the columns and indexes. We made multi-columns also, and we made multi-index also, right? Now what we can do, we can work with the multi-index data frames. So let's get some comfortable with the multi-indexes. Okay, now what we can do, let's say we have this data frame and I will convert this to, I'll make this index as multi-level. So for that, what we can do, we can just apply stack here. So it will become the multi-index. Let's say if I want to access any value, so all will work, the head and tail. Let's say if I apply head, so we will get the top 5 values, the top 5 value. For the tail also, we'll get the bottom 5 values. Let's say if you apply the shape on original data frame, 105,24 means 105 rows and 24 columns, which we fetched from the Yahoo Finance. And if you apply stack here, you will get a different shape, right? 420 rows and 6 columns. And if you apply stack again, you will see that we are getting 2520 rows and 0 column, because now it became a series. So it's very easy, exactly same like which we have seen previously. So for the info also, you will get the same. In info, you will get the 24 columns, right? And if you apply stack, then you will get the info for the multi-index, which explain the column attributes, like how many null values are there, what is the data type of that column. So we can check the duplicated values. So here, if I check duplicated, it will show me like all are false, right? So it's exactly same, no difference. And you have seen that that is the consistency of the Python, right? Now let's say if I want to extract a single row. So let's say we have this data frame and you want to extract a single row. So you can simply write a 0 and you will get the error. Why? Because this is a data frame, and for that you need to use iloc and lock. So when we use iloc, value of the first row, and if you want like from 0 to 5, it's exactly the same, right? And if you apply stack, you will see that it has been changed. And if you want, you can even like save it to another data frame. Let's say SDF and SDF, right? And now let's say if I want the first row, so for that you need to apply the iloc and the index, that is 0, and you will get the value of all the first rows. Now, if I want multiple rows, so for that also, you know that we can use the slices, let's say 0 to 10, and with this step 2. So let me correct this, and you will get the rows with 2 steps. With iloc, we have seen actually already. So I'll just copy and paste it here. And now to extract the columns, we can perform the same thing, that we can give the name of the column, that is adjacent clause, and you will get the whole column, right, with all the rows. And similarly, if you want multiple columns, so for that, you know what you can do. You can give the multiple column names, that is, let's say adjacent close, and you can give close also here, and you will get an error because you have to provide another list, and now you will get the value of both the columns, correct? And now let's say if you want only the apple from the adjacent close, so for that what you will do, you have to provide a tuple. So what we will do, we'll go here and we will provide a tuple, and here, yeah, tuple, and then we can give apple here, and you will get only the adjacent close and the apple, right? Similarly, like you can perform on all the other columns and rows. Now the interesting thing is that if you want to extract both the columns and rows together, so let's say we have this, how we can extract both the index and the columns. So let's say if I want to access the high of Microsoft on 5th of January. So we know that 5th of January is on the index number 3, that is 0, 1, 2, 3, correct? And the Microsoft is on the index number 0, 1, 2, 3, 4, 5, 6, and 7. Simply, I can go here, I can write iloc and 3 and 7, right? And when you hit shift enter, you will see that you will have this value 367.75. Similarly, let's say if you want 24th of May data of Amazon and Microsoft. So for that, what you can do, you can simply write iloc, and you want for the 24th of May. So for that, what you can do, you can simply, like, now you don't know the index of this, right? So let's say you want the data of 3rd of January, right? And you want data of Amazon, Meta, and Microsoft's high of that day. Means the high of Amazon, Meta, and Microsoft on 3rd of January. So it is on the like index 1. So 1. Then you can pass a fancy indexing. So it is 0, 1, 2, 3, 4, and then 5, 6, 7. So you will just write 5, 6, and 7. And when you hit shift enter, you will have the value of Amazon, Meta, and Microsoft on the 3rd of January. Very easy and simple. And just practice few questions and you are good to go. Correct? You can also sort the indexes. Let me show you how. df, and if you give here sort index, by default it will sort because it's time series, so it's already sorted. If you make here like ascending false, then you will get the reverse data, correct? Descending order. Let me show you a few more things. Let's say we have this data frame, and what I'll do, I'll apply a stack here. So what will happen, this column index will come here on the index side. So you can see here we have now two indexes, multi-level at the index side, means this is level 0 and this is level 1. So what I will do, I will first sort this in descending order, and then we will sort this in ascending order, right? So I'll just write sort index, and here we can provide a list. So ascending. So first we want for this descending, so I'll make it false. And for the second one, I want the same ascending, so I'll make it true. And when we hit shift enter, you will see that the first index has been sorted, but the level 1 is still in ascending order. If you also want to make it sorted, or you want to reverse this, you can just change the values. So from false to true, and from true to false, right? And when you hit shift enter, you will see that the level 0 index is same, but the level 1 index has been sorted in the descending order, right? You also have the option to transpose. Transpose means the index will become the columns and columns will become the indexes. Let me show you how. So if you apply on this transpose, okay, let me first show you the original data frame, right? So here we have 2 levels in the columns and 1 level in the index. And if you apply transpose here, you will see that the date time index now becomes the column and both the columns become the index. You can again apply the transpose on this, and now it will again reverse, correct? So it's very easy, simple. And let me show you a few more examples. Let's say I will stack this first, stack. And what will happen? The level 1 column becomes the level 1 index. And if I apply transpose here, you will see that the indexes becomes columns and column becomes the indexes, right? So let me hit shift enter and it says, okay, actually it is transpose, not the transform, transpose. And you will see that the columns become the index and the index becomes the columns, right? Now, the last one is the swap level. So this is the original index. And if you want to swap the levels, like the level 0, level 1. So if you apply the swap level, the level 1 becomes the level 0 and the level 0 becomes the level 1. So let me apply that swap level and hit shift enter. So you will see that it says can only swap levels on the hierarchical index, because on the index we have only one level. So if I apply axis here, axis is equals to 1. Now you will see that on the column side, the levels has been swapped. The tickers is on the top right now and the close and high is on the level 1, right? Similarly, let me show you the last example of this. So earlier we got the error. So for that, what we can do, we can just stack this, and now this index will become the multi-index, right? And now you can apply the swap level here. So by default, it applies on the rows. So now what will happen? This date will come here at the level 1 and this tickers will come at the level 0. So let me hit shift enter and you will see that it has been changed. And if you apply on the axis this time, it will throw an error, because on the axis we already have only one level. So let's say axis 1 and you will see an error. It says can only swap levels on the hierarchical index. Hierarchical means the same multi-index. So for the swap level, you should be having the hierarchical index, correct? So I think that is it for the day. And remaining topics are the long versus wide data and pivot tables and melt functions, just 2-3 functions. And this is also very important. So what you can do, we can schedule a supplementary session for this and I'll explain you these topics, right? So for this video, this is it. And please attempt all the multiple choice questions and perform the task in the GitHub. So yeah, I'll see you in the next video. Until then, bye bye, take care, have a nice day.